I was in the previous presentation about power systems, and I sent Bernd. Yeah, I sent Bernd the message. Let me do an Ignite about power, so you have a little bit more information. So yeah, power your DC. I believe in build your own data center. I like building stuff. I do a lot of stuff with hardware. You can build your own cloud if you prefer the word cloud in place of data center, same thing, more or less. We have a lot of open source software. We are at the Open Source Monitoring Conference, but do we actually have real open source hardware? And most people who work in the IT business and know the Intel hardware, it isn't open source. Most of the other open source hardware is also not really fully open source. Open Power is now fully open source. Even the specifications are online on GitHub. You can just download it. You can build your own processor. You can build your own motherboard. You can build your own server. That's available for the Power 8 and the Power 9. The main difference between the two, well, between this open world is that it's a RISC processor, so it's a reduced instruction set, which means that it needs a lot of additional layers or additional things. Typically, it used to exist in the big endian world. Today, it's bi-endian, so it does also little endian. Most of the Linux distributions are little endian. The Intel world is little endian, so you have a lot of compatibility with it. Another advantage is that you have much more scalability in these. So you have typically 2-socket or 4-socket machines. You have about 12 cores, and you can have up to 192 threads or 384 threads. The Opal is the bootloader. It's fully open source, again on GitHub. Basically, you do IPLing. For people who are old enough, they know what that means. You have then ski boot, which is basically booting up whole your machine and initializing each hardware component. And then you have petit boot, which is basically a Linux kernel running. And at that point, the Linux kernel will run whichever kernel you want, your distribution kernel, basically. On the management node, you have the OpenBMC. So people who in the previous presentation saw that you can do a lot of monitoring on it, but it's fully open source, so you can actually write your own code in there. You can change all the logos to your own logos if you prefer that. You can even compile it yourself and run it yourself on it. Typically, you have 2 types of machine, scale out and scale up. That's basically the difference between the number of sockets. So you even have little machines with 1 socket, which you can buy. So Raptor Engineering actually has a machine called the Blackbird, which you can buy for a few thousand euros, and it's fully open source. You can do all your experimentation on it. They even give you reserve chips, so if you break anything, you can actually repair it yourself, if you know how to do it. You saw a lot of big players in there. They're all busy with power. These are the distributions which are typically available. The ones in bold are the ones that are more supported, which is typically the little endian ones, because that's more compliant with the Intel world. So KVM, Podman, Docker, LXC, you have all possibilities there. Typically, a 1 host machine, that's a 2-socket, will run about 1,000 VMs. I've heard stories that you can even scale it up to 2,000 on the new ones. I haven't tested that myself, but I've tested about 1,000. Commonly, all open source software will run on the power machines. The only thing you might have to do is recompile. So for Go, you need to recompile it. If it's Python or Perl or any scripting language, it will just run there. All the other open source tools, web servers, are typically stuff that migrates very easily. And you actually have the ability to run all applications in a more or less native way. Traditionally, the typical workloads on Power were databases. MariaDB actually has a port which they support where they claim that they can do 1 billion transactions per second on a machine, which if your business is that big, you might want to look at that. Typically, like I said, all open source languages, most of the normal interaction languages which can be compile very easily. The only thing you need to do is recompile your applications. If you want to make use of the exact hardware accelerations. You might have to make a few patches here and there, but typically those are very limited. I have a bunch of them listed, so there's a website, you can find more information about it. Thank you.